Good evening, girls. Here's another try for me to see if I can make this simple for you girls. The last learning outcomes that we have to do, first one is that you need to understand exactly what enthalpy is. Enthalpy is change in heat. We study changes in heat in two different aspects. One is we can look at change of heat in a chemical reaction. The other one is looking at heat when there's changes of phase. So thermochemistry is a study of the changes of heat during chemical reactions and changes of phase. Enthalpy is the heat content of a system at constant pressure. So if we look at a reaction of iron with oxygen, the iron is the system, it reacts with oxygen, so we put it in oxygen. The iron is the system and the oxygen is the surroundings. So when we look at the change in enthalpy, we're looking at this reaction and saying, does this reaction absorb energy or does it give off energy? In this case, energy is being released. So when it's released, we say that it is called exothermic, an exothermic reaction. So that brings us to the fact that we are going to study two types of enthalpy. The one is exothermic, the other one's endothermic. To find out my change in heat, I will take my final heat in my reaction and subtract it from my initial heat. Now the heat is measured in joules. We use the formula Q is equal to mc delta T, and if we see that the heat is being released, we say that that's an exothermic reaction. Some facts that we use for determining whether it's exothermic is that we must make sure that the heat of our products, now remember products is the end of a reaction, that heat is less than the heat of the reactants. If the heat of my products is less than the heat of my reactants, which was the start of my reaction, I will always get a negative value, and that means it's exothermic. It is the opposite for endothermic reactions. That's the first outcome. It's what is enthalpy. The second learning outcome is how do we write thermochemical equations. In a thermochemical equation, we will write out the chemical reaction just like we do with any chemical reaction, but at the end we will indicate the change in heat by delta H, triangle with an H, and the chemical heat value. So this will be the combustion value for iron. The meaning of this is the negative means it's an exothermic reaction, and then because this value here, 1625 kilojoules, that is the amount of energy that is given off if iron is burned in oxygen. So that is for 1 mole of iron. If I have more than 1 mole, my energy will be more. If I have less than 1 mole, my energy will be less than that. So the energy is 1625 kilojoules, but the negative symbol tells me that it's exothermic. So that's the amount of energy that's given off. The negative tells me it's exothermic. In reactions where the heat is actually absorbed by the reaction, that will be indicated with delta H being positive. So when I look at the end, this will tell me whether I'm working with an exothermic or an endothermic reaction. You will remember we did exothermic and endothermic reactions, the first practical that we did, and that's also the one that you did your performance tasks on.